A tightrope walker steps onto a thin wire. The wire is narrow. The ground is far below. In the walker's hands is a long pole. It looks simple, but that pole is doing two important jobs. First, it helps control the center of mass. To stay balanced, the combined center of mass of the walker and pole must remain above the support line, the rope. If the center of mass shifts too far to one side, gravity creates a torque. The body begins to rotate and fall. A long pole gives the walker a way to shift mass left or right. When the walker leans slightly one way, the pole can be moved the other way. This shifts the combined center of mass back toward the rope. The pole does not remove gravity. It gives the walker better control over where gravity acts. Second, the pole increases rotational inertia. Rotational inertia is resistance to changes in rotation. A long pole spreads mass far from the walker's body. That makes it harder for the system to start rotating quickly. The fall becomes slower, and slower is safer. If a person on a rope begins to tip without a pole, the body can rotate quickly. There is little time to react. With a long pole, the same tipping motion develops more slowly. The walker has more time to feel the change, move the pole, adjust the feet, and recover. This is why the length of the pole matters. A longer pole places mass farther from the rotation axis, increasing rotational inertia more effectively. Sometimes the pole is slightly weighted at the ends. That makes the effect even stronger. The pole may also sag slightly, placing some mass below the walker's hands. This can lower the combined center of mass, making control easier. But the pole is not magic. It does not make the rope wide. It does not guarantee balance. It only gives the walker more control and more time. The common misconception is that the pole simply adds weight. Weight alone is not the point. Where the weight is placed matters. Mass spread far to the sides changes how easily the walker rotates. Mass moved left or right changes where the combined center of mass falls. The tightrope walker survives by constantly correcting tiny errors before they become large ones. A step, a lean, a pole movement, a correction. The science is the same as in many forms of balance. Keep the center of mass above the support and slow the fall enough to respond. From a distance, the long pole looks like a prop. In reality, it is a control system held in two hands. It gives balance a wider language, and on a wire, that extra language can be the difference between walking and falling.